I recently made a video restoring this massive IBM PS2 tower. I then made a second video turning it into an almost perfect DOS Adventure gaming rig by installing the proper hardware. I say almost perfect, because a perfect period correct machine like this obviously needs a sound blaster. But that is a massive problem. Sound blaster cards for the weird and wonderful MCA slots in this PS2 are among the rarest sound blaster cards you can get. Luckily, TubeTime has made a clone, so let's build one and see if it's any good. This project has been around for a few years now, so there are pre-built modernized versions of this card available. If you're not into soldering, that could be your best option. But that's not what we do on this channel. I don't mind some soldering, and I want a vintage look and feel of the original card. So instead I ordered some PCBs from the sponsor of this video, PCB Way. In fact, I wanted it to look even more like the original card, so I asked Guru for some help, and he helped me with some changes to these PCBs. It's not meant to fool anyone, it's still quite different from the original card, but it has the right vintage look and feel. I think it looks great. So big thanks to PCB Way for the PCBs and to Guru for the help in making the changes. Let's start building and we'll talk some more about the card later. Let's start with the smallest parts first. There are a few obsolete parts to this project. I'll show you which parts in a minute, but the rest is still available from your favorite electronic supplier. So first up we have the CPLD. When soldering this chip, you need to make sure that the marking on the chip and the PCB lines up. And then we need to align all the pins with the pads. I'm gonna have to do the alignment off camera, and I will solder 2 of the pins to secure the chip in position. Said and done. Now the chip is aligned. I used some flux and soldered this pin here and this pin, so now the chip doesn't move around. I'll add some flux to all the pins, and then I'll add some solder to the tip, and then drag solder all the pins on the other 2 sides. This method here will create some bridges, but I'll ignore them for now and we'll remove them later. The important thing here is not to use any pressure, because it's quite easy to bend one of the pins. Now we can drag solder the other 2 sides. Being careful not to use any pressure. Okay, with all 4 sides soldered, we can now remove all the bridges. You can clearly see the large blob of solder here. I removed the bridges by drag soldering a few more times and clean the tip in between. And then I'll just repeat on all 4 sides. For drag soldering, I use a tip with a flat surface, because it can keep quite a lot of solder. I'm gonna clean up the flux right away and inspect all the pads before I move on to the next component. I use a dry Q-tip first and scoop up most of the flux. And then I use IPA to clean up the rest. If you don't clean up most of the flux with a dry Q-tip, it's just going to create a bigger mess. And here's the finished result. It may look a bit difficult if you've never done this before, but it's not. It's actually quite easy to solder one of these chips. Next up we have this tiny voltage regulator. So TubeTime has also made an ad lib replica for the MCA bus. We have built one of those cards for the Model 50 projects. When we did, I didn't think to solder the voltage regulator early on, and it was a bit trickier to reach with larger components surrounding it. I'll add some flux, align the chip, and then solder one of the legs. And then I'll make sure it's properly aligned, and then I'll solder the remaining pins. I'll clean the flux up as I go, while it's easy to access. And here's the result. That looks okay. Before we move on to the through-hole components, We have a few SMD caps. These are tiny little buggers. I highly recommend getting a few extra in case you drop them on the floor. I'm gonna have a second go at a tiny tip that we tried out in a previous video. It was too small for electrolytic SMD caps, but for these tiny little caps it's perfect. This tip is absolutely tiny. I think it's about 1 millimeter thick. You don't need a tiny tip like this for these caps, but I rather like it. I added a few more of these off camera. They were 9 in total, and apparently I have a new favorite tip for tiny components like this. By the way, there are detailed instructions on TubeTime's GitHub page if you're planning to build one of these. Okay, I ran into a small problem here. This is a really large card, so it doesn't really fit in my PCB holder unless I mount it like this. So this is going to be a bit flimsy and far from ideal. I'm going to start with some small components and then move up to the larger components. Let's start with the resistors. So this card was originally called the Sound Blaster MCV, and it's based on the Sound Blaster 1.0 from 1989. The Adlib sound card came out in 1987, and both the Model 50 and the Model 80 were also released in 1987, so that would be an appropriate choice. However, the Model 80 we're working on now is a late Type 3 machine, so this card is actually more period correct for this build. Now here's something to watch out for. R10 here is a regular 39K resistor, but R13 here is a 39.0 with 1% tolerance. So don't mix these up. I skipped ahead a bit and installed all the resistors. By the way, I have been using the new shorter tips available for the Pinesil lately, because I thought it would give me more control. But now that I have used both for a while, I actually prefer the longer tips. The PCB is really flimsy when mounted like this. So I wonder if there's a larger version of this PCB holder. Okay, I skipped ahead and installed all the resistors. There are tons of them. This is a large project. Next up we have these axial caps. They are 0.1 micro 50 volts. I cut the legs a bit shorter on these, so it doesn't get as messy on the other side of the board. Those resistors were a bit of a pain to solder because they were overlapping each other, so I had to keep bending the leads out of the way. When I solder through-hole components like this, I bend the leads to prevent the component from falling out. When that leg is soldered, I bend the other leg up and solder it. When that lead is soldered, I go back to the first lead and bend the lead up. This way it's going to be much easier to replace if anyone needs to repair this card or if I make a mistake. And then of course I cut the leads off. Next up we have some beads. L1, 2 and 3. And now we can move on with the sockets. I'm gonna skip U14 and U15 because CMS is not implemented on these cards, but hopefully there will be someday. The original card didn't have any sockets, but I'm gonna put all the chips in sockets. So I install one row and then I tape them down. I only solder 2 of the pins, roughly in the middle of the socket. And then I make sure they are flush to the board before I solder the remaining pins. We better install D1 and D2 next, before we move on to larger components. And these are 1N4148 diodes. We also have a few 5.1 volt Zener diodes. Next up we have the crystal. This may not be necessary, but I'm going to add an extra wire to hold the crystal down like on the original card. There's probably not enough flux in the solder to solder the wire to the crystal, so let's add some, and I'll place a large blob of solder on top of that wire. Next we have T1 and T2. I had to bend the leads so they would fit these through holes here. And these are 2 N3904s. These PCBs are very clearly marked, so there isn't much room for mistakes here. These boards also have a few resistor packs. RP1 here is 2.2K. RP2 and 3 are both 1K. Next up I'm going to install a whole bunch of ceramic caps. There are tons of these on this board and many different values, so I'm gonna skip ahead here not to bore you. Just a quick word about this row of caps here. Only 2 of the caps are marked, C20 and C29. And you've guessed it, of course. These are C21, 22, 23 and so on. And Guru also marked what chip goes in what socket, to make it even easier to assemble these boards. This board also has some electrolytics, so C40 here is a 100 microfarad 16 volt cap. The remaining electrolytics are all 10 microfarad 16 volts. These caps are quite tall compared to the rest of the components on this card, so you may want to consider low profile caps instead. They are probably a bit more expensive, but I think it could be worth it. Next we have the audio jacks. I don't seem to have ordered a MIDI connector for this project, but I think I have one laying around somewhere, so we'll fix it later. And instead we'll start installing some chips in all those sockets. I skipped ahead to the obsolete chips, except for this guy here, but it needs to be programmed, so we'll take care of it later. So the remaining 4 chips are obsolete, and you're gonna have to find these on eBay. So first off we have a 3403AD. This is an op-amp. It could probably be replaced with a modern part, but I went with the original chip. And this is actually the chip that delayed this project for a week. Next is a Signetics NE558N. This is basically 4 555 chips in one. If you can't find one of these, you can actually build replacements on tiny PCBs. There is a link to that project on TubeTime's GitHub page. But I went with the original chip from China. And apparently it came with a bent pin. So let's fix it first. And the next chip is a DAC from Yamaha. It's Y3014B. I have found plenty of these on eBay. And the final obsolete chip is the Yamaha OPL2, the YM3812. This is the chip that does all the magic. These are actually rebadged chips. I wiped one of these with acetone and the damn text came off. However, the chip I wiped actually worked, so I only think they replaced the text to get a series of matching dates to make them appear as new old stock. So if you find one of those chips on eBay, it's probably a working chip, and I wouldn't worry too much. Although I think it's shady business, so they really shouldn't do that. I almost forgot the pin headers to program the CPLD. So let's install them before we start programming. Instead of regular pin headers, I'm going to use angled pin headers and install them backwards on the back of the card. This way I can power the chip from this side of the board and program the chip from the other side. Let's see if this works. It does. So the pins coming through to this side of the PCB are long enough to attach the cable for the programmer. To program the chip, I'm going to use a DLC 9LP clone. The cable for the programmer is clearly marked, and so is the PCB. We're in luck. I found a used connector in my stash, so we might as well install it before we program those chips. Well, we might as well fix the bracket. There are files so you can print these, but I found a blank in my stash, so I thought I'd try to make one. But this thing is tough. I managed to drill a couple of holes for the audio jacks here, But it took some effort, and it got so hot, it actually got discolored. So the tough part is going to be to make this hole here for the joystick connector, because of its odd shape. This is really messy and noisy, so I'm gonna step outside and drill a couple of holes here, and then try to enlarge that hole with a Dremel. Wow, that was some really tough piece of IBM steel. But eventually I got it done. I drilled a hole, one in each corner, and then I used this cutting wheel for the Dremel and cut this piece out. And then I cleaned all the edges with this tip here. And except for those discolorations here, it looks pretty perfect actually. Way better than I expected. Together with the blank, I also got this plastic bracket in IBM blue. I'm going to install it with the rivets. I think that's how it was originally installed. I also have the spare piece to mount at the back of the card. But before I install it, I'm going to add some PTFE so it will slide easily on those tabs. And as expected, it fits perfectly. And here's the final result. That took some serious effort to make that bracket. If you want to make a bracket like this that looks original, you better be a patient person. Okay, I'm running out of time here, so I'm gonna have to cheat and point the camera on the display. So to program the two chips, you need to download this hex file first, and then load the file into XG Pro. The first chip we're going to program is the AT89S51, and then it's just the usual stuff. Install the chip in the ZIF socket and click Program. So this chip is really easy to program. The CPLD is a bit more tricky to program. First you need to create a folder on your desktop. Call it what you want, but you need to download this bitstream here and place it in that folder. The next step is to download Oracle's VirtualBox. I went with this version here. The installation is very quick and easy. This should be done in a couple of minutes. Next I downloaded Xilinx IC 14.7. There are other ways to program this chip, but this is the way I do it. I went with this version here for Windows 10, but I'm running Windows 11 on this machine, so I hope it will work. Okay, now it's downloaded, so let's install it. Supported operating systems Windows 10. Okay, fingers crossed. Installation cannot be performed. Please fix the issue before installing. Virtualization is not enabled in BIOS. Please enable before installing. Okay, I'll fix it and skip ahead here. Well, I did some troubleshooting, and virtualization was already enabled in BIOS. So something is messed up here. This is a Prime Z790P board, by the way. And apparently there is some compatibility issue here, but I did some troubleshooting, and in this bin file here we've got this script file. So if we open this file up, this script here seems to be checking if virtualization is enabled, but for whatever reason it's not compatible with my motherboard. So I'm going to comment out this if statement here and save the file. Now let's run the installation again. Okay, fingers crossed. An untested installation of Oracle VirtualBox was detected on your machine. You can continue with the installation. I think this might be working. Let's give this a try. Better agree to all of this stuff here. And here's the important part. During the installation, we need to select the directory to share. And of course, I chose the folder we made on the desktop. Okay, it's installing, so I think this is working. I'll skip ahead here. The software is slow, really slow. It takes forever to download and install. Okay, installation completed successfully. And now we can start the software with the impact icon. Sorry for recording the screen, by the way, but I just don't have any time left this week to capture the display. Okay, it didn't actually start impact. So let's try from inside the virtual machine. That's better. And in here you need to click OK. And yes. And OK again. And then you should get an error, because the chip is not hooked up yet. The pins were a bit too short for the cable, so I removed the plastic housing from the pin headers. Now the cable fits perfectly. On this side of the board we need to connect 3.3 volts. I'm just going to use my bench power supply. With the board connected and powered, we can now click OK and restart the virtual box. And again, double click on impact. Yes, OK, and yes. And then we're asked for the configuration file. And that's the file we downloaded and placed in the folder on the desktop. So let's choose it and hit OK. Okay, and we're all set to program the CPLD. Just right click and program. Program succeeded. And that's it. The CPLD is now programmed on the sound card. It's quite cumbersome and time consuming, but it's pretty straightforward. If you want to have a go, just follow these steps and you should be okay. I'm the type of guy who likes to verify. So let's do a quick check of the content of that chip. Verify succeeded. Okay, we're good to go. Okay, a quick look at the card before we install it. It doesn't look like the original card, but it definitely has that proper IBM PS2 look. This card looks great. I'm tempted to keep it on display instead of installing it. Oh, I almost forgot. There's one more important thing here. All the sockets on this board are pointing to the left, except for the 40-pin socket here. So don't make the mistake of installing this chip backwards. And it actually was backwards on the original IBM card too. Okay, AdLib card removed. And instead I'm going to install the Sound Blaster. Well, it fits perfectly. That's a good start. If you want to build one of these AdLib replica cards, I'll put a link at the end of this video to the video where we built this card here. Drivers for PS2 systems come in the form of ADF files. The file is available at GitHub page 2. I downloaded a copy and placed it on the reference disk for this machine. Okay, let's boot up the system from the reference disk. It's counting up to RAM. We're getting a 165. That's normal, it means found new hardware. This is sort of like plug and play. Way before plug and play was a thing. Automatically configure the system, yes or no. I'm gonna hit yes. And that's all we need to do to install a card in an IBM PS2. If you have the ADF file on the reference disk. Automatic configuration program is complete. Now let's reboot the system back to the reference disk. And hopefully we will see our installed card. Okay, no 165 this time. I'm gonna go to set configuration and then view configuration. And down here we have the Snark Barker MCA by TubeTime. Awesome, all good so far. Let's reboot and see if it actually works. Okay, let's jump into the Prince of Persia folder and run setup. And in here I'm gonna go down to sound device and change to Sound Blaster. And same thing for music synthesizer. And exit to DOS. Okay, fingers crossed. No time for troubleshooting. It better work. I heard a click in the speakers. Yes! It works. The delivery guy just stopped by with yet another package for this IBM, so there will be one more video about this PS2. It's probably not going to be the next video, but when it's done there will be a link to that video on the screen shortly, probably in 2 weeks. And that was a good time to watch the restoration video of this epic IBM tower. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.